In 8.6, solving rational inequalities, we're going to kind of solve these pretty similar to how we did in solving rational equations, except we're going to do some shading and we're going to have interval notation here. So the first thing we're going to do is get this set to 0, whether it's less than 0 or greater than 0. So I'm going to subtract 2. The next thing you're going to want to do is make sure you have one single fraction, because the idea is we're going to eventually try to get all this in factored form and everything. It's always easiest and best to do that if you have one entire fraction. And here we have just two terms. One's a fraction, the other one's a separated term, but you can always imagine these both as fractions, like 2 over 1. So if we want to get a common denominator, the common denominator would be just 3 minus x, which I would need to multiply this by on the right side. And then we would rewrite. So we have x minus 5 over 3 minus x minus 2 times 3 minus x also over 3 minus x. And then since they're both over 3 minus x, we can just go ahead and put it all over the common denominator, 3 minus x. You would then try to simplify the numerator, so I could distribute that 2. And since we're subtracting, it's like we're distributing the negative 2. So that will give me negative 6 plus 2x. And then all of that is less than 0. Simplifying further, we can combine like terms. So here we have x and 2x, which is 3x. And then minus 5 minus 6, so minus 11. And sometimes it does help to rewrite this all in standard form order, where we have x's first, constants later. So we could write this as x minus 3 on the denominator, negative x plus 3 on the denominator, sorry. So looking at this, we have a numerator and a denominator. I would say try to factor it further if you can, but this is already as factored as it can be. There's no GCF and there's no trinomials or difference of squares type of thing here. So essentially we're going to find two things. The two places where a rational equation, if you would graph it, would change signs from positive to negative or negative to positive would be any x-intercepts and any vertical asymptotes, assuming their multiplicities were odd. So just like how we had to graph these, we identify the x-intercepts, the vertical asymptotes, and we just know they will alternate signs between them. So here we have an x-intercept of 11/3, and then we have a vertical asymptote of positive 3. And you're going to put both of those on a number line. So 3 comes before 11/3. Then from here, you can pick numbers in between each of these intervals and then plug them in. Just make sure you plug them in everywhere, top and bottom to all the x's. And that could be one way to determine signs, positive and negative. Or we can do what we did last chapter, where we could identify the end behavior, and that will tell us positives or negatives. And then we know if signs are going to change or not based on the multiplicities being odd or even. Now looking at this, if I had to discuss about end behavior, here I look at the degrees. And the degrees are the same, 3x over negative x, all each the first. So when the degrees are the same, we would identify a horizontal asymptote, which would be dividing these two, so negative 3. So my end behavior is negative 3 on both ends, and negative 3 is negative. Then 3 was a vertical asymptote. The multiplicity of that would be odd, 1. So therefore, it must change signs from negative to positive. Then the 0 11/3 was one of our x-intercepts, which came from this top factor, which also has an odd multiplicities. Therefore, it must also change signs from positive to negative. If you wanted to confirm this a different way, I could have picked a number like 0, which would have been over here in the left region. If I would plug 0 into the x's, I would have 3 times 0 minus 11, which is negative, over, and then negative 0 plus 3, which is positive. A negative divided by a positive would give you a negative result. And once you determine what one sign is, because the multiplicities were odd for the vertical asymptote and the x-intercept, we just know they would change signs after that. So minus to plus, and then plus to minus. Then like before, depending on your inequality, if it's less than like this, we'd shade all the negative portions. It's not equal to, so open. And then write the solutions in interval notation. Negative infinity to 3 and 11/3 to infinity. So the last part is nothing new from the last couple chapters. All right, let's look at number 2. So this one's already done for you. It's already all into one side. It's already one fraction, so it's ready to go. So what we're going to first do is identify any x-intercepts or vertical asymptotes. In order to do those, I'm going to make sure we factor everything we can. And on the top, we can factor x plus 3, x plus 4. So here I have two x-intercepts, -3 and -4, and then I have a vertical asymptote at 0. So I'm going to put those three numbers on a number line in order. -4 first, then -3, and then 0. Then we can determine the sine values. Now this one's going to be a little different than before because we did not talk about what happens when the degree is bigger on the top. If you want to know more about that when I come back, I can definitely explain that. There are tricks for that. So let's just say for now, let's plug a number in and see what happens. So let's plug an easy one in like 1, which is in the right section. If I would plug 1 into each of these variables, into all the x's, what will we get? If I plug 0 into the first one, 0 plus 3 is positive. If I plug 0 into the second one, 0 plus 4 is positive. Sorry, 1, we're plugging 1 in. 1 plus 3 is positive. 1 plus 4 is positive. Then if I plug 1 in the bottom, 1 itself is positive. So I have a positive times a positive, then divided by a positive. Ultimately, this whole area is positive. Then 0 is a vertical asymptote. Its multiplicity is 1. Therefore, it must change signs. It must be negative then. -3 is an x-intercept, which also has a multiplicity of 1. Therefore, it must change signs. And then finally, -4 is another x-intercept, also a multiplicity of 1. It must change signs one more time. So this would be a minus plus rational inequality. Now, it's going to shade all the graders, so all the positives. And it does say equal to. So we're going to have to talk about this for a second. Normally, I would just say, hey, if it's equal to, shade in solid circles. But we want to be very careful about this, about equaling 0. Is it okay if -4 gets plugged in, and will it be greater than or equal to 0? If you plug -4 in, you would get exactly 0, because if you plug -4 into this factor right here, -4 plus 4 is 0. 0 times something would be 0, and then 0 divided by something would still be 0, which is equaling the 0. So that is perfectly fine. We can have -4 be one of the solutions, and we would shade in -4. Same idea with -3, we would shade that in. 0, on the other hand, was not an x-intercept. If I plug 0 into this inequality, I would not get 0. I would get something divided by 0, which is not 0, it is undefined. It's a domain restriction. You're not ever allowed to equal to whatever makes the bottom 0, or whatever is the vertical asymptote. So we need to have an open circle on that 0, and make sure we do not include 0 as part of my solutions. So the way I will write my interval notation is close bracket -4 to -3, union, and then open parentheses on the 0, since we cannot equal to 0, it's a vertical asymptote, and then fades to infinity. And I think that's the only tricky ones from here. Let's try one more. Let's do number 9 together. So what I want to do here is first subtract 1 to make sure everything's all over onto one side. And that's less than 0. And then we want to get common denominators, which would be to multiply this guy by x plus 1. Then do a top and bottom. Multiply this by x minus 1. Do that top and bottom. And then finally multiply this fraction at the end by x minus 1 and x plus 1. And we don't ever have to worry about the 0 because it's all going to multiply to 0 anyways. So when I combine and simplify, we will have 5x plus 5. Then when I distribute this minus 2x, we would have minus 2x squared plus 2x. And then I would just minus 1 times x minus 1, x plus 1, which we know is x squared minus 1. And then that's all over the common denominator, x minus 1, x plus 1. Or you could write x squared minus 1. Continuing to simplify, we can combine our like terms. We have negative 2x squared with this minus x squared. So we have minus 3x squared on top. Then the x's, we have 5x and 2x. And then the constants, we have 5 minus negative 1. So it's going to be a plus 1 and plus 6. Then for the numerator, to find our x-intercepts, we're going to want to try to get factors for that. Now, I don't like that negative being in front, so I'm going to factor that out first. And then I'll try to factor that as a trial and error. 3x times x will work. And then if I do 3 here and 2 there, that would make a minus 9x with a plus 2x, making a minus 7x in the middle. And then those numbers will multiply to either ends. So here we have 4 different numbers that are x-intercepts or vertical asymptotes. We have negative 1 for a vertical asymptote. We have negative 2/3 as a x-intercept, positive 1 as a vertical asymptote, and positive 3 as the other x-intercept. Looking at this problem originally, we will have negative 3x squared over what would have been x squared, so they are same degrees. We have a horizontal asymptote of negative 3. Negative 3 is negative, and it's flat, so it's going to stay negative on both ends for the end behavior. Excuse me. Then we have all odd multiplicities for every asymptote and every x-intercept. So that tells me the sign's going to change every time. So minus the plus, plus the minus the plus, and of course, at the end it should change. There are no equal to's, so I don't have to worry about any closed circles whatsoever. So I'm going to open circle everything, and it says less than 0, so shade all the negatives. Now let's pretend it did say equal to's. Here's how this would be different. The 1 and the negative 1 would stay open because they're vertical asymptotes. But the negative 2/3 and the 3 are x-intercepts, and it's okay for those to be 0 because they do equal 0 when they're on the top. And if we want to be equal to 0, x-intercepts is the way to go. So my last thing is to write the interval notation, negative fitting to negative 1, negative 2/3 to 1, and then 3 to infinity. If you guys have any questions on the remaining 7 problems, be sure to let me know, and good luck.